Okay. So we were seeing detailedly about single tuned amplifiers in the last class. So we derived the expression for bandwidth. Uh, you know the expression for resonant frequencies f not equal to 1 by 2 pi root of LC. So we had a very big circuit considering the hybrid pi model of that amplifier, and we simplified the elements, making them parallel into a single component. Finally, at the output side, we had only one RLC parallel. We found out V out, and we found out V in. We found out the ratio A is equal to V out by V in. We equated that to 1 by root 2 and found out the bandwidth. So the bandwidth, what we got was this one. I hope you remember the expression. So this is what is the bandwidth we got. Bandwidth equal to omega naught by QE, or bandwidth in terms of R and C is bandwidth equal to 1 by RT into C radians per second. If you want to convert that into frequency, you will have 1 by 2 pi RT into C. And if we plot the graph, we can see at one particular frequency f naught, the response is maximum, and away from that, it exponentially decays. And we have also seen one important relation between Q factor and bandwidth. So as the bandwidth is large, the Q factor is less. And it is vice versa. When the bandwidth is less, the Q factor is more. Okay. So Q factor will help in selectivity. The Q factor, a very high Q factor, will help in selecting or tuning to a particular frequency very easily. So general requirement for single tuned amplifier is the Q factor should be as high as possible, which will automatically make the bandwidth as small as possible, because omega naught is going to be constant. This omega naught is not going to change for a particular tuned circuit. So today we will see what happens if I'm going to cascade multiple single tuned amplifiers. So assume that if gain from a single tuned amplifier is not sufficient for me for a application purpose, I need to boost that. So for that, I'll be connecting multiple single tuned amplifiers in cascade. General observation, what you know, when you connect amplifiers in cascade, the overall gain will increase. So when gain is going to increase, the bandwidth is going to reduce, because gain bandwidth product is always going to be a constant, right? So same thing we are going to see it. We know the answer in prior. When I'm going to cascade many stage of single tuned amplifiers, effectively my gain will increase by a huge amount. Naturally, the bandwidth will reduce by the same amount. So we know that. Now we are going to mathematically prove how this is going to happen. So in order to obtain a very high gain, it is usual practice to connect several stages of amplifiers in cascade. So you know, when you do such cascading connection, the overall gain is product of the individual gain. If two amplifiers A1 and A2 are connected in cascade, the overall gain A will be equal to A1 into A2. I have told this, many students make mistake. They add the gain. The gain is not additive. The gain is multiplicative. When will the gain add? Means in dB scale. If you convert A1 into dB, if you convert A2 into dB, you know, when you take logarithm of product, it becomes equal to sum. Correct? So when you have in dB scale, you have to add. When you have in numerical scale, you have to multiply their overall gain. Okay, so this very high voltage gain will always make the amplifier have a narrow bandwidth. So you cannot have an amplifier which has a very high gain and very high bandwidth. It is literally impossible. So it is not at all possible to have an amplifier having very large gain and very large bandwidth. That is practically impossible. So naturally, when you cascade multiple single tune amplifiers, the voltage gain will be very high. The bandwidth will keep on becoming narrow. So we are going to consider n stages of a single tune amplifier in cascade, where n is a number which is greater than 1. Okay, minimum number of amplifiers for cascading is 2. Okay, so we generalize it to be n. So we are going to find what is the gain and bandwidth of such an amplifier which has n cascaded stages of identical single tuned amplifiers. And all the amplifiers are going to have the same resonant frequency